Alright, so let's continue for the recurrent relations for the arithmetic sequence. So just now you already learned the recurrent relation for the general format. It means how to convert from a sequence to a recurrent relation, and what is the recurrent relation. So right now I'm going to deep inside to arithmetic sequence. How to write a recurrent relation if you know this is an arithmetic sequence. Okay, so let's look at here. This is for only for arithmetic sequence. So remember what is arithmetic sequence? A pattern which is involved plus and minus. So let's see over here. An arithmetic sequence is one in which the difference between any two consecutive terms in the sequence is constant. That means any pattern which is involved plus and minus, and you have a common difference. So the first term in the sequence is A, and the common difference between the terms is D. Okay, so right now over here, I'm going to write down for you. The question say D is equals to T2 minus T1. So maybe I just put down over here D, they say equals to T2 minus T1. At the same time, also is same as T3 minus T2, third term minus the second terms, or you can have terms 4 minus the term 3. So basically D over here you can interpret as always the next terms minus the previous terms. Okay, so next term minus the previous terms over here. So actually for the recurrent relation for arithmetic sequence, so you look at here, they say the general first order recurrent relation. This is so-called the general ones. So from the general, we can convert to a arithmetic sequence by substituting the R is equals to 1. So when the question have recurrent relation, which is arithmetic sequence, you can straight away using this recurrent relation formula. So I write down, I have two formats over here for you to see. So you can give Tn plus 1 equals to Tn plus D, where your T1 is equal to A, or you can write the other format, which is Tn equals to previous term Tn minus 1 plus D. You can put it as T1 or T0 equals to A. It's up to you, depends on the question. If the question say is initial, that means you need to start with T0. Alright, so just the difference is if the question have initial, you just have to start with T0. So let's look at the example. So example 2, find a recurrent relation that generate the arithmetic sequence. So they ask you to find a recurrent relation. So this is arithmetic sequence. So what is the recurrent relation for the arithmetic sequence? So recall back. So Tn plus 1 equals to Tn plus D, and where your T1 is equals to A. So this one is the recurrent relation for the arithmetic sequence. If the question asks you for the n terms formula, so remember is Tn equals to is A plus n minus 1 D. So do not forget that this is n terms, and the question is asking for recurrent relations, or the question asking for the recursive rules, or the question asking for different equations. So this is a different equation. So you have the sequence 30, 27, 24. So your A value over here will be 30, and what is the common difference? Common difference, find out the pattern. Every time you decrease 3, so it's minus 3, minus 3. So this one is minus 3. So you just have to substitute into your, that means the recurrent relation, general one. Tn plus 1 equals to Tn minus 3, and your T1 is equals to 30. You just have to learn how to substitute. It's not going to be so tough. You know your D. Your D is negative 3, so that's why I straight away substitute. My A will be 30. How I get this one is from my answer over here. Okay, so this is how to do for the recurrent relation for the arithmetic. So let's continue. So they say the general terms or the n terms of an arithmetic sequence is given by Tn a plus bracket n minus 1d, which is just now I mentioned. So a sequence is defined by the different equation. So different equation means the recursive rules. Recursive rules. So you have a recursive rules Tn plus 1 equals Tn minus 8, where T1 equals to 4. So find a rules for the n terms of the sequence. So I want to remind you, find a rules over here is stand for find the general formula or general rules, general formula. Okay, so general formula, this is a sequence, and if you look at this sequence over here, Tn plus 1 equals to Tn minus 8, when you have T1 equals to 4. So actually this recurrent relation is the arithmetic. This one is the arithmetic recurrent relation. So if arithmetic recurrent relation, you can compare what is the general recurrent relation. Tn plus 1 equals to Tn plus d, where your T1 equals to a. So right now, after you compare, your d will be negative 8, your a will be 4. So if you're asked to find the general formula, are you able to? So Tn equals to a plus n minus 1d. Your a will be 4. So n minus 1 you don't know, but you know your d is negative 8. Put a bracket over here. So therefore it becomes 4 minus 8n plus 8. So it becomes 12 minus 8n. This will be your Tn value. So sometimes students ask me, can I leave this one? That means I don't want to expand the equation. Can I leave this one as my answer over here? Yes, it can. You can, yeah, but I do not encourage. But always encourage students to write as this form. Simplify the equation and the formula. Okay, so that's how to generate the recurrent relation for an arithmetic sequence. Okay, so let's look at the example 4. The 7 terms of an arithmetic sequence is 35 and the common difference is 4. So question 8, find the first term of the sequence. So using all the information that you learned in the previous sections, T7 is 35. And given any other information, common difference is 4. And no, this is arithmetic sequence. Okay, so I'm going to find arithmetic sequence. The general formula will be Tn equals to a plus n minus 1d. Okay, so I just have to change this T7 into a general formula, which is a plus 6d equals to 35. So this one is from over here. T7 I change to a plus n minus 1, that means 6d. So your d is given, which is 4, 35. So your a will be 35 minus 24, so which is 11 over here. So I find the first term. So how about B? Write down the recurrent relation that describe this sequence. So recurrent relation for the arithmetic sequence will be Tn plus 1 equals to Tn plus d, where your first term over here equals to a. So do you know the d common difference? Yes. So you just substitute, rewrite again. Tn plus 1 equals to Tn plus common difference 4, where your first term right now is 11. Okay, so this is quite common question already to ask the recurrent relation. Please remember how to write. You get 1 mark for stating the initial terms, and you write 1 mark for getting the correct recurrent relations. Okay, so let's look at other questions. Okay, so over here we already done for the recurrent relation for the arithmetic. So let's look at the geometric sequence. So how is the recurrent relation for a geometric sequence? So they say geometric sequence is one in which the ratio of any two consecutive terms in the sequence is constant. That means for a geometric sequence is involve multiplications, and you are going to get a pattern which is related to multiplications, and that pattern over here will be your common ratio R. So your recurrent relation for the geometric will be this one, straight to the point, because you will learn the general form later on as well. So for the geometric, you just have to remember the recurrent relation will be Tn plus 1 equals to R Tn, where your first term will be A, where just now your arithmetic will be Tn plus 1 equals to Tn plus D. T1 equals to A, but just the recurrent relation for geometry is R times Tn only. So you know the A and you know the R. So let's look at example. So example 5. Write the geometric sequence. This is a geometric sequence as a recurrent relation. So first step, write down the first term. So your A will be 72. So find the common ratio over here. So how to find the common ratio? Should remember. So using the next term, negative 36 divided by 72, or you can using 18 divided by negative 36, or you can also using negative 9 divided by 18. So you will get over here is negative 1 over 2. So this one will be your common ratio. And write down the recurrent relations. So general recurrent relation is Tn plus 1 equals to R times Tn. So maybe I just write down Tn plus 1. Your R over here is negative 1 over 2 times Tn. And your first term over here will be 72. So you get 2 marks straight away. So continue. So the general terms or n terms of a geometric sequence is Tn equals to AR power of n minus 1. So you learned this one in the high school. So express the geometric sequence defined by the rules. So you define by this one as a recurrent relation. That means you need to find a recursive rules for this question. So look at the formula for this part. Your A is equals to 4. Your R is equals to 0.25 if you compare from this formula to this formula. So first step, write down the rules for the n terms. So the rules for the n terms over here, Tn equals to AR power of n minus 1. Identify the value A and R from the given rules. So your Tn equals to 4, 0.25 power of n minus 1. So identify A is equals to 4, where my R is equals to 0.25. So write down the recurrent relations for the geometrics. So the geometric, you have Tn plus 1 equals to R Tn, where your T1 equals to A. So next is you just have to substitute the value of A and R. So Tn plus 1, my R is 0.25 Tn, where my T1 equals to 4. Okay, so done for solving these recurrent relations. So example 7. So example 7 over here say that the fourth terms in a geometric sequence is 1 to 8 with common ratio which is 2. So find out the first term. So T4 is equals to 1 to 8, where you have your common ratio which is 2. So you write here general formula for this one, AR power of 3 equals to 1 to 8. You have R is 2. So 2 power of 3 equals to 1 to 8. So 2 power of 3 will be 8. So A will be 1 to 8 divided by 8. So it will be 16. So your A will be 16. So question B, write down the different equations. So it's RTN, whereas T1 equals to A. So your Tn plus 1 equals to R. Your R will be 2. n, and where your t1 is equals to 16. So that's how to solve. So thank you for listening to this video.